All right, so I gave you a warm-up that involved exponentials and their properties. We said the reason why we're doing this is because logarithms are exponentials. They're equal to the exponent that you can't solve for. So properties of exponents are going to apply also to logs. So to remind ourselves of these properties, when I multiply 2 to the 6th times 2 to the 8th, what do I get to do with their exponents? You get to add them together. So this becomes what? 2 to the 14th. Beautiful. Okay. If you went one step further, it is equal to 16,384, but you didn't have to. You could stop right here. All right, number 2. We have 3 to the negative 2 and 3 to the 5th. You get to add those together again. So what is negative 2 plus 5? It is 3, so this becomes 3 to the 3rd. All right, what do we get to do with exponents with things like 3 and 4 where we are dividing? What? Subtract. We're going to subtract our exponents. So what is 12 minus 4? 8. And then how about number 4? When I have 3 minus negative 1, that actually gives me a positive 4. So this is going to be 4 to the 4th power. All right, the last one, I have 7 cubed raised to the 5th. So when you have a power raised to the power, what do you do here? You get to multiply them together. So you're going to say 3 times 5, so 7 to the power of 15. Beautiful. Good. 6 and 7 were reminding you of what we did yesterday. And remember those 2 special logarithms that we talked about? That also apply to the exponential properties. So how am I going to rewrite log base x of x equals to 1? You can draw the e, right? Start with the x and make our loop. So base of x raised up to the power of 1 equals x, right? There we go. Does that make sense? X to the power of 1 is x. We talked about yesterday that was a special property. Whenever you have the base and the value that's the exact same number, it'll always be equal to 1. All right. Number 7, if you wanted to move this equals 0 to the other side, it's not going to change anything. Some people don't like it on that side. I don't care. I need this to be an exponential as well. So what are we going to do? X to the power of 0, because our base always comes first, and our last 2 numbers switch, equals 1. Or you could have drawn the e for this one also. Does that make sense? X to the power of 0. This is representing no matter what your base is. Okay? If it's in a log of the number 1, it's always going to be equal to the exponent of 0. That's what your exponent had to be. All right, questions about our warm-up? All right, we're going to move on to properties of logarithms. There are 4 special properties. We dealt with about 3 of them in our warm-up. You actually already did one of them yesterday. That was this one. Okay, so we're going to kind of go back to this towards the end. We're going to deal with the main 3 operations first. The first one we're going to do is going to be our product property. All right, so product property of logarithms. All right, so in words, it is the logarithm of a product is equal to the sum of the logarithms of its factors. Okay, I gave you an example with numbers. So if I have log base 3 of 1,000, I can actually separate it. It's called expanding. 1,000 is the same thing as 10 times 100. So I can split this up into 2 logs by saying log base 3 of 10 plus log base 3 of 100. I'm able to split it up into 2 different logs by its factors. All I could also go the other way. I could also condense it, which is what our examples are going to be. We're going to condense them back together. And then algebra way, it's showing that log, no matter what the base is, of two values multiplied together, you can separate it with a plus sign in the middle. So just like our exponents, right? When we had two exponents, like numbers 1 and 2 from your warm-up, you were able to add your exponents together, right? Because you were multiplying like bases. That's how this one connects. So just like our exponentials having like bases, our logs will also always have like bases. Looking at A right here, I have log base 6 of 4 plus log base 6 of 9. Now when we give these to you, your bases have to be the same, and honestly, we'll make sure that that always happens. Okay? Your base will always be the same. If for any reason in the future you come across one of these problems and your base is not the same, then you can't do this property. Okay? Just like exponentials. If I had 2 cubed and then 4 squared, I can't combine that. All right? Your bases must match. All right, part A, they do match. So I'm going to combine them by bringing them together. So log base 6, I can multiply 4 times 9 together. And what is 4 times 9? 36. Good. So that is log base 6 of 36. I have expressed this as a single logarithm. It means I have brought it together, or there is just one log into my equation. Then it says evaluate using mental math or a calculator. So this is an actual number. Remember, logs are equal to exponents, right? So what is the exponent that we're missing here? What is this log equal to? Remember, we're thinking 6, technically we're equal to x, right? This is equal to a number. 6 raised to what equals 36? 2. Good. So when I solve this, log base 6 of 36 is equal to 2. If the mental math you're not able to get right away, remember you have a calculator, you can use that as well. You push your math button, you push your up arrow, and you should see the log base function there for you, and type in base 6 of 36. All right, let's try our next one. All right, log base 5 of 625 times log base 5 of 25. Since there's a plus sign in the middle, they have the same base, I'm going to multiply these two factors together. So I'm going to have log base 5 of 625 times 25. All right, what does that give me? It should give you, 15,625. All right, so we've expressed it as a single log. That part is done. Now it tells me to evaluate. So I'm going to put it in my calculator. I don't think you know 5 raised to what exponent gives you that nice large number. No, it should be 6. Yep, it should just be 6. That's the same thing as saying 5 raised to the power of 6 is equal to 15,625. Bless you. All right, how do you feel? I want you to try number 6. We have log base 8 of 4 plus log base 8 of 16. And then you have log base 4 of 64 plus log base 4 of 1024. So try these either on your own or with the neighbor. I'll give you a minute. Express as a single logarithm, and then also evaluate, either using mental math or you can use your calculator. Once you get an answer, compare it with your neighbor. Make sure we're getting the same thing. What you looking for? You good? Okay. We good? You ready? All right. What was your single logarithm for 6a? Log base 8 of 64. Good. How did you get 64? You multiplied 16 times 4. Oh, that went right in the middle of it. So this gave us log base 8 of 64. Good. And that is equal. How did you evaluate that? What's that equal to? The number 2. Good. Because 8 squared is 2. All right, part B. When you expressed it as a single logarithm, we had log base 4 of what value? Yeah, 65,536. You got that by multiplying 64 and 1,024 together, right? All right, and then when you evaluated this one, it is equal to what? It is equal to 8. Beautiful. All right, so how do we like the products property? Good. You see how it's connecting to those exponential properties as well? Same base, we got to add those exponents. Here, same base, we get to multiply. Remember how these are inverses of each other? Okay. All right, let's go down to our next one. It's called the quotient property. So we had the product, now we have the quotient. All right, in words, it is the logarithm, or the logarithm of a quotient is the logarithm of the dividend minus the logarithm of the divisor. So with multiplication, we got to separate it by a plus sign. When we're dividing, we get to separate it by a minus sign. Okay. If it's already separated with a minus sign, we get to bring them together by dividing them. You'll always take the first number and divide it by the second number. The example I have for you is log base 5 of 16 over 2 can be expanded to be log base 5 of 16 minus log base 5 of 2. And then you should be able to go either way. Expand it out or condense it together. Algebra-wise, it says log base b of m over n is equal to log base b of m minus log base b of n. That is showing you that the top number will always be first when you expand. Or if you condense, your first number will always be in the numerator of your division. All right, let's practice. Here I have log base 5 of 100 minus log base 5 of 4. I see a minus sign, so I can bring 100 and the number 4 together by dividing them. So I'm going to get log base 5 of 100 divided by 4. I get to bring them together. What is 100 divided by 4? It is 25. So that becomes log base 5 of 25. I have expressed it as a single log. Now I'm going to evaluate it. What does that equal to? Meaning 5 raised to what is 25? 2. Good. Again, some of these are easier with mental math. Some of these require a calculator. I don't care which way you do it. All right, log base 7 of 49 minus log base 7 of 7. So I'm going to bring 49 and 7 together by doing what with them? Dividing them. And which one of those will be my numerator? 49. So it becomes log base 7 of 49 over 7, right? Which simplifies to be log base 7 of 7, which is equal to what? Just the number 1. Beautiful. That was part of our properties that we learned yesterday, that we reviewed this morning in our warm-up. Again, we had to think to ourselves, 7 raised to what gives me 7 again? Power of 1. All right, you try number 8. So express it as a single log, and then tell me what it is going to be evaluated to be. You have log base 3 of 108 minus log base 3 of 4. And then you have log base 4 of 80 minus log base 4 of 5. Again, once you get an answer, make sure you are checking with your neighbor to see if we're getting the same thing. As we move forward, these properties will get put together, so it won't just be one. Like you might have a plus and a minus sign. Just be prepared. This is very basic. It will get more complicated. Make sure you always read things from left to right and do the properties as you see them. So if it's a minus sign first, you divide and then you'll multiply. All right, we good? Ready? Okay, the first one, how did you combine 108 and 4? You divided them. Why did you divide them? Because the minus sign. Good. So when you divided them, you end up with log base 3 of what value? 27. Good. And this is equal to what? 3. Because 3 raised to what is 27? 3 raised to 3 is 27. All right, part B, 80, we got to divide it by 5 because of the minus signs. So that gave me log base 4 of what? 60? 16, okay. Which is equal to 2. Awesome. Still feel good? Yeah? Yeah, because remember, we got to get the foundation strong, so when we do start building these things together, you'll be okay. All right, our next property is going to be the power property of logarithms. In words, the logarithm of a power is the product of the exponent and the logarithm of the base. So in numbers, I have showed you log of 10 raised to the power of 3 is the same thing as saying log of 10 times 10 times 10, which we just learned I can separate by adding them together. So if I have 3 of the exact same thing, I can do 3 times log 10. Okay? Essentially what happens is I get to take my exponent and I get to move it to the front. So log of 10 raised to the power of 3, I can bring the 3 in front and have it 3 times log of 10. Okay? So with the power property, I get to take my power and drop it in front. So when we're expanding things, we're going to drop it in front. If it ever asks us to condense, that's when we put the power back up as an exponent. So depending on which way we're going. Algebra, we have log base b of a raised to the p power is equal to p times log base b of a. All All right, so looking at example A right here, 9a, we have log base 2 of 8 raised to the power of 6. See how also this, it's important of how you write your numbers, how small they are, where they're positioned, because I need to know that the 2 is the base because it's small and towards the bottom. I need to know that 6 is the exponent because it's small and it's being raised up. Okay, so it does matter how you write these numbers. All right, to simplify this one, to express it as a product, I'm going to take my power of 6. I'm going to move it to the front. So this is now 6 times log base 2 of 8. That's how you express it as a product. Now I can evaluate it. Log base 2 of 8 is a number. What is that number? Type it in. Or think to yourself, 2 raised to what equals 8? Power of 3. So log base 2 of 8 is equal to the number 3. And what is 6 times 3? 18. Good. All right, next one. I see I have a log base 8 of 4 raised to the power of 20. I'm going to take my 20 and move them to the front of this problem to get 20 times, whoopsie, my paper touched the board. There we go. Let's try this again. There we go. 20 times log base 8 of 4. All right, now I need to evaluate it, so I'm going to actually figure out what log base 8 of 4 is. 0.67 or 2/3. Yep. So again, you push the math button on your calculator, you push the up arrow, you saw log base. You gave it a base of 8, a value of 4, and it came out to be 0.67. Now we're going to multiply that by 20, and you should get about 13.33. So this goes to show my answers won't always be nice whole numbers, and that's going to be okay. To be honest, most of our stuff, as we move forward, there's lots of fractions and decimals, and you're going to be okay with that. All right, you try 10. I got 3 examples for you this time. There's an A, a B, and a C. So I have log 10 of 4. Log 10, raised to the power of 4. Then you have B, base 5 of 25 raised to the power of 2. And then we have log base 6 of 54 raised to the power of 2. Once you get answers, compare them to your neighbor. How come there's no base written on A? What? Yeah, it's a base 10. What is that called? Remember, I had a special name yesterday. Look in your notes. Very first page was part of your fill in the blanks. Common log. There you go. So common logs have a base 10 that we don't have to write the actual base with it. Share your answers with your neighbor. See if we're getting the same stuff. We good? What was the first thing you did with A? Brought my 4 down to the front. Good. To 4 times log of 10. How did you simplify log of 10? What is it equivalent to? To 1. Good. So you have 4 times 1, which is equal to 4. Good. All right, part B, what did you do first? brought my 2 down. So you have 2 log base 5 of 25. How did you evaluate log base 5 of 25? It is 2. So my evaluation here is equal to 4. Last one, part C. What did you bring to the front? 2. That's my exponent. 54. There we go. Log base 6 of 54. It's not a whole number, right? 6 raised to not a whole number is going to be my evaluation. So what did you get when you typed it in? About 2.23, 2.2. I'll take either one. We usually like to go to 2 decimal places, so I'm going to say 2.23. What is 2 times 2.23? About 4.45-ish. Good. Very good. So we're good with product, quotient, and power. Right? Those are our 3 main ones. 3 main operation properties of logarithms. Do you see how they all connect to the exponential properties from our warm-up? Good. All right, one more property today. It's the inverse property. We've actually already kind of touched on this a little bit. So we're just going to do a little bit more. So inverse properties, remember that these are inverses of each other, exponentials and logarithms. So when I have the 2 bases together of a log and an exponential, they're actually going to cancel each other out. Okay? So remember my base has to be bigger than 0. It also cannot be equal to 1. All right, inverse property. If I have a log with base b, and then the value is that same base being raised to an exponent, I can actually cancel everything out except for the exponent. So the example, I have log base 10 of 10 raised to the 7th. Since those 2 10s are next to each other, they get to cancel out, and just 7 is left. The next one, if I have a base that's raised to an exponent of a log with the same base, the base and the log gets to go away, and the value is left. The example is 10 raised to the log base 10 of 2. So 10 log 10 get canceled off, and 2 is left over. So when the bases match and they're next to each other, they're running away into the sunset. Best friends. They're going to go live their happy life. And then the exponent's left out. Gets left behind. All right, so 11a, I have log base 3 of 3 raised to the power of 11. So since I see 3 and 3 together, they're going to run away. I am left with just 11. So my answer for A is just 11. That's it. The bases cancel, my exponent's left. Now part B, I don't see 2 bases that are the same, right? Log base 9 of 81. Could I make it happen though? Yeah? How? Yeah, I could rewrite 81 to be 9 squared. And then when I do that, now I have log base 9 of 9 squared. My log base 9 and 9 go away. My answer here is just 2. So sometimes you might have to change the value to get the same base, if it's possible. C is actually an exponential, but in the exponent I have a log, 5 raised to log base 5 of 10. So I have 5 log 5. They're together. So my answer here is just going to be 10. Not bad, right? So whenever your bases are the same and they're right next to each other, they're going to run off into the sunset. All right, you try 12. All right, what is our answer for A? 0.9. Yep. What is my answer for B? 8x. Good. My bases are the same. Remember, this is the common log, so my base here is 10. So log 10 gets to run away. 0.9 is left over. 2 log 2 gets to run away. I'm left with just 8x. All right? These were very basic. Sometimes you're going to have to arrange things, move things around to make this happen, or change our base, or if there was a value that I could make into a power. There's different things you're going to experience later on. But this is the very basics. If you can ever make it to where your logs and your bases are the same and they match, and they're right next to each other, you can cancel them out. Right? Remember when I said I was going to do multiple properties of one problem? You ready for that? Yes, you are. You can do it. All right, look at bringing it all together. So 13, we have log base 4 of 3 plus log base 4 of 6 minus log base 4 of 2. So all my bases are the same. They're all base 4. Okay? I see a plus sign and a minus sign. I'm going to do the properties moving left to right. So what property are we going to do first? Product, quotient, power, or inverse? Product power first. Good. So I'm going to take log base 4. We're going to multiply 3 times 6. And then that minus sign tells me I'm going to then do what? Subtract. Do my quotient. Yep. So it's going to be 3 times 6 and then divided by 2. All right, what is 3 times 6? 18. And what is 18 divided by 2? 9. So this simplifies to be log base 4 of 9. If I asked you to evaluate it, what would that answer be? About 1.58. Good. My directions here just say condensed, so technically we were done when we got log base 4 of 9. I just went an extra step. All right, you do 14. Log base 7 of 2 plus log base 7 of y plus 2 log base 7 of x. So there are actually 3 properties present in this one. And there's no evaluating because I have some variables. So all you have to do is condense it into just one logarithm. What property do you want to do first? Product, quotient, power, or inverse? Product is first. How do you know? Left to right, I see a plus sign. So what am I going to multiply together? 2 times y. That becomes 2y. Then what are we going to do? Yep, use our quotient property to divide. And what are we dividing this by? X squared. There you go. Yeah, because this last one had a 2 in front. Yeah, so you can do power property, make it come back up. So when you are condensing together to a single log, you want the exponent. Okay? When we're expanding it out and stretching it out, that's when you move it to the front. So I think expanding makes it longer, right? Condensing it makes it as small and short as possible. So we're going to divide by x squared, and this one is done. All right, so 13 and 14 were both the condensing examples. 15 and 16 are my expanding ones. So now I want to use my properties to expand and stretch it out. You ready? Okay, let's do it. Number 15, I have log base 3 of 4 times x to the 5th. Tell me what you see happening. Ignore the log base 3. Just look at 4x to the 5th. What operations are occurring here? Multiplication. And we have an exponent. We have power, right? So we're going to separate this by using product property and our power property, right? Do the power property last because this 5 is only going to the x. So if you move it to the front right now, you're going to apply it to both 4 and x, and that's not true. Okay? So we're going to separate the two. They both get a log base 3, right? Log base 3 of 4. And then we have log base 3 of x to the 5th. What's going to go in between them? Plus sign. Good. Yep. Product property means I get to add together two logs of the same base. All right, and then my last step, we'll do power property. My first log, log base 304, does not have anything else to do with it. That piece is done, so I'm going to leave that alone. Log base 304. I'm still going to add. My second piece is the one with the power. So I'm going to bring that power of 5 in front of just that log. So this is going to become 5 times log base 3 of x. Sorry, it kind of skips on me. It's better. So I've expanded it out. It is nice and long. There's nothing else I can do to separate pieces. Feel good? All right, I want you to look at 16 and just think about it for a second. I have log base 5 of the square root of x. I don't see a product, I don't see a quotient, and I don't see a power. But could you make one of those things appear by rewriting? I see some nods. What are you thinking? What could we do here? How could I rewrite the square root of x? Almost. Almost x squared. You're on the right track, though. It's going to be an exponent. What exponent is the same thing as being a square root? 1/2. There you go. Remember doing that back in our radical section? Yes, so we can rewrite it to be log base 5 of x to the 1/2. Now I have an exponent. Now I can do my power property. So I'm going to move 1/2 to the front. This becomes 1/2 times log base 5 of x. And that's all I can do with that one. All right, do you have any questions for me at all? Or do you want to do another example of something? Because I can make up another one. No? You feel good? Okay, I'm going to make something up real fast. What if we are condensing? Okay. Here we go. Someone give me a number 1 through 10. Beautiful. Someone give me another number. I don't care what it is. 4? What else? 3? And then give me one more. Okay. So if we have log base 7 of 4 minus log base 7 of 3 to the x plus log base 7 of 2, okay? And I told you to condense it, bring it all together. All right, this time, what symbol do you see first? You see a subtraction, right? Which means I'm going to divide first. So when I bring it together, the only number that's going to be in my numerator is 4. After this, everything else is in my denominator. Okay. So 4 divided by 3x, yeah? 3 to the x times 2. 3 to the x times 2. And that's all you would do. Yeah, that's all you do. The exponent was already an exponent, so you don't have to move it anywhere. When you bring it together, it should stay up top. If the x was out front, I would have taken it and moved it up here. So I just wanted to show you the other way too, if the minus sign came first, what that meant for the rest of our problem. All right, you good?